Okay, this is quite a tricky question. We have P A union B. We have P probability A given B and P probability B given A. And we want to find PB and PA intersect B in terms of X. And X is just a shorthand what we're calling PA. So we know, or we pretend to know, the X, we're calling it PA. Now, we're looking for intersection and we're looking for B. So let's take the pieces of information we know and see if we can rewrite them in another way. So A union B can be written as A plus B minus the intersection. So that's good because the intersection is the thing we want. And A, that's okay too because we want our answer to have A in it because we're calling it X. Now what about this one here? That is probability A given B, 0.4. That's A and B, again that's good, over B, which is fine because we also want B as well. Also, this one here we can say is 0.5, and that's B and A, or A and B, it's the same, over A. And again, A, we can just call it X. So we have three equations. This is equation 1, which has X, PB, and A and B in it. This is equation 2, and this is equation 3. And we have to think about the best way to put them together. So we want A and B, and I think this is the best one to give us A and B. A and B, that would equal 0.5x. So that one's done. Now what about getting B? Well, I could use that equation, or I could use that one. I'm not sure which would be best. I think I will use the shorter one, the second one. I can say PB equals PA and B over 0.4. I only want to have X in the answer though, because it says in terms of X. So I can sub this into this. I'll get PB equals PA and B, 0.5x over 0.4. 0.5 divided by 0.4, that's 1.25. So we get PB equals 1.25x. Okay, so we have PB, which is what they wanted in terms of X. And we have PA and B. So that's part A done. Part B is to find X. You'll notice I haven't used the first equation. So if I use the first equation, I get 0.84 equals X plus PB, which I said is 1.25x, minus PA and B, which is 0.5x. So it's like 1x plus 1.25x minus 0.5. So we get 0.84 equals 1.75x. So x equals 0.84 divided by 1.75, which is 0.48. So that's the x. And then what's the last part here? Oh, we have to draw it in the Venn diagram. Okay. A, B, A and B, where's that? That's this one here, which is 0.5 times x. So if you multiply that out, you would get 0.24. And then this one here, 1.25 times 0.48. That would work out to be 0.6. So if that is 0.6, it means that this has to be 0.36. So the total can be 0.6. A, do we know A? A is x, and x is 0.48. So that forces this here to be 0.24. So the total can be 0.48. And since everything has to add up to 1, it forces this here to be 0.16. So everything can add up to 1. So finally, are A and B independent? Let's check that out. Probability A times probability of B, that would be 0.48 times 0.6, which is 0.288, which is not equal to A and B, the intersection. So the answer is no, they're not independent, because the probability of A, which is 0.48, times the probability of B, which is 0.6, is 0.288, which is not the intersection 0.24. So, sorry, this bit squished in on the page, isn't it? But there you go.